Let us see the mechanism of anionic addition polymerization. There are actually 4 steps involved in this. The first step is the formation of anionic species or nucleophile, which initiates the chain initiation reaction. The anionic species are formed from anionic initiators. There are similar to addition free radical initiators, cationic initiators. There are anionic initiators that gives the anionic attacking species or nucleophile. Okay. For example, alkyl sodium, alkyl lithium, or aryl lithium, or alkyl sodium, aryl sodium, or Grignard reagents, organometallic reagents, are used as anionic initiators. For example, N-butyl lithium undergoes dissociation to give R minus N-butyl anion plus Li plus. This initiator is completely, the initiators are completely ionized in the presence of polar solvents, whereas in the non-polar solvents, the anionic initiators are not completely ionized. Therefore, the study of kinetics is complicated in the presence of non-polar solvents, where there is partial dissociation of anionic initiators. The second step is the chain initiation step. The attacking species, the anionic species formed in the first step, attacks the monomer molecule to form M1 minus, The monomers are having electron withdrawing substituents, only undergoing this anionic addition polymerization reaction, whereas monomers having electron releasing substituents undergo cationic addition polymerization reaction. Okay. So what are the electron withdrawing groups? CN, COH, phenyl group, etc. The third step is chain propagation step. In this step, the M1 minus formed further attacks another monomer molecule to form M2 minus. This is M1, M2 minus. Therefore, M1 minus plus M gives M2 minus. Further, M2 minus reacts with the another monomer to give M3 minus and so on to give Mn minus. In general, M1 minus, M2 minus, Mn minus are represented as M minus. This is a polymer anion. The final and the fourth step is chain termination step. In the absence of impurities, there is no chain termination step. This is similar to condensation polymerization reaction, where there is no chain termination step. However, whereas in the presence of impurities such as water, acids, the anionic addition polymerization is quickly terminated. That is by combination of acid H plus with R minus gives R minus plus H plus gives RH. Okay. Thus, the chain is terminated in the presence of impurities. Good morning. In this class, we will study about anionic polymerization. What is anionic polymerization? Mechanism, kinetics. Anionic polymers are also called living polymers. Anionic polymers are also called living polymers. It involves the attack of anionic species. This is very similar to
cationic polymerization and condensation polymerization reaction, please watch the cationic polymerization first. It involves the attack of anionic species, for example R minus or nucleophiles on the monomer having electron withdrawing group. This is electron withdrawing groups such as cyanide, COOH, NO2 group, etc. For example, styrene. Styrene is a monomer with the electron withdrawing group, phenyl electron withdrawing group. Therefore, styrene undergoes anionic addition polymerization reaction. Whereas isobutylene, we have studied earlier, isobutylene, monomers having electron rich substituent or electron releasing substituents undergoes cationic addition polymerization reaction. Okay, it is very similar to free radical initiators, cationic initiators. There are anionic initiators, for example, alkyl lithium, aryl lithium, alkyl sodium, aryl sodium, Grignard reagents, and these are all organometallic compounds having carbon is directly bonded to, in organometallic compounds, carbon is directly bonded to carbon. Metal is directly bonded to carbon. Metal is directly bonded to carbon. And also basic amines, alkoxides are also used as anionic initiators. They are represented by I. Okay. Similar to condensation polymerization reaction, there is no termination step here. There is no termination step. The chains, since there is no termination step, the chains continue to grow. The chains continue to grow until all the monomers are exhausted, until monomers are present. If there is no monomer, the chain will not grow because there is no termination step involved. Further, the chain end, anionic chain end is more stable than cationic chain end. Therefore, the growth of the polymer can be resumed by the addition of same monomer to give AAAA, or the monomer growth can be resumed by the addition of different monomer B, for example B, to give block copolymers. So, anionic polymerization is of very much importance for producing different kinds of polymers. For example, block copolymers, similarly star copolymers, etc. Okay, therefore, since the ionic chain end is stable, it is called anionic polymers are called living polymers. Let us now study I have given the mechanism separately at the end. Please watch that. Let us discuss the kinetics of anionic polymerization now. The M1 minus further attacks the monomer to give M2 minus, and M2 minus further attacks another monomer to give M3 minus, and so on to give Mn minus. Okay, so on Mn minus. Therefore, the rate of propagation is also equal to the rate of overall anionic polymerization reaction. The rate of propagation is directly proportional to monomer concentration and polymer. This is M2 minus polymer active anionic chain, living chain polymer. Okay, polymeric chain, active anionic living polymeric chain, Mn minus, or in general M1 minus, M2 minus, Mn minus are represented as M minus. Okay. In the absence of impurities, there is no termination step, and also negligible association or complete dissociation of N-butyl lithium. For example, anionic initiators are completely dissociated in the presence of polar solvents, because these are polar compounds, R plus R minus. These are anionic initiators are polar compounds. Therefore, they are completely dissociated in the presence of polar solvents. Okay. In such cases, the concentration of active anionic polymeric living chain is equal to the initiator concentration. In such cases, okay, that is, each initiator starts a new growing chain, starts a single chain. Okay, therefore, each growing chain starts simultaneously and react with the monomers at equal rate. Each growing chain competes with the monomer at equally. Therefore, all the polymeric chains formed are of same length. All the polymeric chains are of same length, and they are monodisperse polymers. They are called anionic polymers, or called living polymers, or monodisperse polymers. That is, the number average molecular mass is equal to, for monodispersity, number average molecular mass is equal to weight average molar mass. We have already studied in part 1 in polymer chemistry. Okay. Therefore, on substituting M minus equal to I naught in this expression, this equation 1, therefore you will get this, and the rate of propagation or the rate of polymerization is equal to the rate of disappearance of monomer with respect to time. The rate of disappearance of monomer. Therefore, on rearranging this equation, you bring M here, therefore M here minus, you bring minus here, minus Kp I naught. On integrating between the two concentrations, M naught, where M naught is the concentration of the monomer in the beginning, where M is the concentration of the monomer at time t. At time t, that is time equal to 0 at time t. On integrating this equation, you will get dx by x is ln x, therefore ln M to give k minus kp I naught t. Therefore, natural logarithm M by M naught minus kp I naught t. This is the logarithmic form. This is the exponential form. This can be converted into exponential form and written in the exponential form. Okay, therefore M equal to M naught e power minus kp I naught t. Okay, now the degree of polymerization or kinetic chain length is defined as the average number of monomer molecule present in a single chain. That is calculated by using this relation. The degree of polymerization is calculated by using this relation. That is M naught, concentration of M naught minus M divided by I concentration of initiator concentration in the beginning. That is concentration in the beginning minus concentration remaining at that time t. Therefore, that gives monomer, the concentration of monomer that is reacted. If you subtract these two, you will get the monomer concentration that is reacted. Okay, on substituting M here, you will get this expression. By using this expression, the degree of polymerization can be calculated. You will be given, for example, in CSIR and the GATE, they will ask a problem based on this. They will give you the monomer concentration, initiator concentration, the propagation rate constant, initiator concentration and time. Then by using this equation, you can calculate the chain length, average chain length. Okay. So thank you for watching. You will see the mechanism in further. Thank you.